Just going to look at some questions then, really, just so you've got an idea of what's going on. So we've got this function. It must give you the domain, so it's anything greater than or equal to 2, basically. And this is right down in terms of k, the range of f. Well, again, if I look at the smallest value that it can take, it's 2. So if I substitute that in, then I get 8 plus k is the smallest, at least the smallest value it can take. And that goes at the other end of the domain up to infinity. So again, 4 times infinity plus k, well, that's just going to be infinity. So there we have it. It then goes on to say the function g has domain greater than or equal to -3 and defined by this. Find the least value of k so that the function g of f can be formed. Now, I'm just going to do exactly what I've shown you previous, in that I'm feeding f into g, so I'll start off with my f of x, and we can see what the domain that's being fed into it, is this, and what comes out we've already discovered is this. And then, as I've shown you, I'll write down my g of x here, and what this can take the domain in theory is -3 and infinity. And then here we can see what is an apparent mismatch. This function can only accept -3 or greater. So we have to fix it so that this here is always greater than or equal to -3. So we just select x plus k is greater than or equal to -3, and we solve this. K is greater than or equal to -11. So the least value that k can take is -11, is the least value. We don't mind if it's more than that, because, for instance, if k was 10, we'd have 18, and that's fine because 18 falls within this interval. So that's that question, part of the question done. And then you won't have any problems with C1. I mean, that's just algebra, forming the composite function. And finally, in that composite function, you are going to substitute in the value of 2, set it equal to 7, and solve. Now let me just check. Right, surprise, surprise, this is going to be a quadratic that you're going to solve. There will be 2 values of k, and you have just got to bear in mind that we said that k has got to be greater than or equal to -11. So one of those values is undoubtedly going to be less than -11, which you'll discard. But I'll let you have a practice with that. The previous year, nothing complicated here. We're finding the inverse, you're swapping your x's and your y's. Again, as always, the skill is finding the range. So you check, in this function, the extremes, what the extremes would be, and the range becomes the domain of the inverse function. Let's have a look at this question. So yes, we're going to swap our x's and y's around. Logs and indices here, so I know it's going to be testing your algebraic knowledge of the laws of logs and the rules of indices, so it's an algebra question really. Writing out the domain, well, that's when you have got to be able to find out what the range would be with this function. So again, you can substitute in the extremes of the domain and see what you get. And this is quite nice. Again, it's just another algebra question. It doesn't talk about domains and intervals, so you're going to substitute the algebraic expression f of x into g of x. So that is a algebra question really. And here's something that, again, we're back to what we're a bit more, need to be more on the ball with. Write down in terms of k the range of g. So if I look at g, the domain of g is 2 and infinity, so greater than or equal to 2. So the smallest value it can take, if I substitute in 2, would be 2k minus 4. And if I substitute in the largest value, infinity, infinity times k minus 4, well, that's just going to be infinity. So find the least value of k so that function f of g can be formed. I'm going to use this method, and again, do use this method, in the absence of any other method that always works for you, because it is versatile, so it won't just help you with this specific type of question. So I'm feeding g of x into f of x. So I'll start off with my g of x. What I'm feeding in terms of the domain is 2 and infinity. And what came out, as we discovered, was 2k minus 4 to infinity. I'll write down my f of x here, and what the domain of f of x is. And again, here we have an apparent mismatch. The high end of the interval's fine, but here the smallest value that this can take is minus 2. So consequently, the smallest value 2k minus 4 can take is minus 2. So we need 2k minus 4 to be greater than or equal to minus 2. And so we're just going to solve. And so there we have it. K has got to be greater than or equal to 1. So the least value it can take is 1. 5 would be okay, because 2 times 5 would be 10 minus, that would be 6, and 6 would fit in the interval here. So, that's it done really. This is just forming an equation, which you can do. It's an algebra thing, and then once you form the equation, you're going to substitute in 3, set it equal to 0, and solve. And again, you're going to end up with a quadratic, so surprise, surprise, one of your k's is bound to be, less than 1, which you will discard. Again, what you haven't been asked to do in this question is to find the range of the composite function, but again, you just see, having chosen your value of k, whatever that might be, and if you choose k to be 1, then you will get the full match between minus 2 and infinity, and then you would see what you would get. Just to be clear, let's say the question said, for some reason, take k to be equal to 5. Then in that case, if k was equal to 5, then 2 times 5 is 10, 10 minus 4, so this would be 6. So you'd have 6 going in. That's fine, because this function can take a value of 6. But what you're going to have then is, the smallest value going in here, consequently, although it could take minus 2, it's actually only ever going to see, it's never going to see minus 2, minus 1, 0, 1, 2, 3, 5. It's only going to take 6. And so it's on this basis that you would work out the range of f of x. Yeah, so hopefully that'll be helpful. The quick video is unpolished, so it's quite possible I've made a few slips with intervals and things, but so just bear with me. But hopefully that gives you an idea, and in particular, how I've laid out these questions should be useful.